For our last example in section 1 of chapter 8, we're going to look at the measure of each interior angle and the measure of each exterior angle. I'm going to kind of summarize right now what we've learned so far. We've learned that the sum of the interior angles is equal to n minus 2 times 180. And we've also learned that, that the sum of the exterior angles is equal to 360. What we're doing in this section is the measure of interior angles and the measure of each exterior angle. So basically, the measure of the interior angle would be this right here, and if I extended one of these sides out, the measure of the exterior angle would be here. I'm going to call this MI, because it's the measure of an interior angle. I'm going to call this ME, where this is sum, all of them added together. This is all of the exteriors added together. The measure of one interior angle ends up being the sum of the interior angles, which is n minus 2 times 180. And we take that number and we divide by n, which is the number of sides. So if you look, if I add all of these together, which is 12, all 12 of these, and I get a total, and I divide by 12, I'm going to find out what one of these is. Similarly, for the measure of an exterior angle, we know this is going to be 360 divided by n, because all of these added together always equal 360. All the exterior angles, this one, plus that one, etc. All of these angles will equal 360. If we divide it by the number of angles there are, that will give us the measure of one exterior angle. Another thing to notice, and I'm going to write it in here, if I extend this side out right here, these two angles together equal 180. So the other thing you need to notice, and this will be the very last thing that I do, if I do the measure of the interior angles plus the measure of the exterior angles, that equals 180 all the time. Again, because this angle plus this one right here would end up giving us 180 here. Alright. So we're going to find the measure of an interior angle on the dodecagon. And since dodecagon means that n equals 12, oh, that's written poorly. So since this means that n equals 12, we're going to find the measure of an interior angle, which is n minus 2 times 180 divided by n, where n is 12. So 12 minus 2 times 180 all over 12. Or in this case, 10 times 180 divided by 12. I'm going to need a calculator here. So 10 times 180 ends up giving us 1800, and we divide that by 12. So 1800 divided by 12, that gives us 150 degrees. So what we're saying literally is that this angle right here is 150 degrees. Now if we extend this out, remember I told you that this angle plus this angle equals 180. So the easy way to find the measure of the exterior angle would be to subtract 150 from 180. But we're going to use the formula, and we're going to say 360 divided by n here to find this measure of this exterior angle. We know it's 360 divided by n is 12 in this case. So if we do that, we end up with 30 degrees. And again, if you notice, measure of the interior plus measure of the exterior should equal 180. They're supplementary because 150 plus 30 equals 180. If you have a choice of using either of these two formulas, what I would do is use this formula to find this and then subtract from 180 to find this. But that's my choice. So again, we find the sum of the interior angles using n minus 2 times 180. We end up with 1800. We're going to divide that by 12 because that's the number of sides. 1800 divided by 12 is 150. So we get 150. For the second part, we know the sum of the exterior angles is 360. So we do 360 divided by 12 to get 30. And there's our answer there. And then the last part, it says an interior angle and an adjacent exterior angle form a linear pair. How can we use this fact to find the exterior angle measure? Well, what we do is we find the interior angle and then use that subtracted from 180 to find the exterior angle. What I would do is actually find the exterior angle first and then subtract that from 180 to find the interior angle. And we're done here. Thanks.